Okay, now members, we are going to see something new, and this is called a line or lines. A line is, we are going to start with the definition, we see the gradient, we see intercepts, we see the nature of the gradients as we are going to see further. Let us start with the definition of a line. A line is a path that gives a relationship between the x and y coordinates or points that lie on it. To get a equation of a line, we only need 2 points on that line. So whenever they are asking you to get the equation of a line, you just need 2 points on that line. Okay, the general equation of a line. The general equation of a line that gains at least 2 points A and B is given by this. So whenever I see this is how we write an equation of a line. So this is the yellow. Y is equal to 2mx plus c, where m is the gradient of a line, and then c is the y-axis intercept. So the gradient of a line, it can also be called a slope. So if m is positive, it's an increase. You see that line is going to be increasing. Now, where it touches the y-axis, that's what we call the y-axis intercept here. Then to get a gradient, of course the gradient is given by changing y over changing x. So how do you get the changing x? So if this line is from this to this, it means that the change in x here is going to be this x2 minus x1. Then the change in y from here up here, from y1 here up to y2, is going to be y2 minus y1. So that's how we get the slope. Now the slope is given by change in y over change in x. We have seen that change in y is y2 minus y1, and change in x is x2 minus x1. Now, this m is the gradient of this line. As you see, I wrote it in a general form. Then, the gradient of a line segment between 2 points A and B. So then, let's see the nature of gradients or slopes. So we have this carry-forward. We have the positive gradients. This occurs when an increase in, whenever we move in this direction, we are increasing x, and whenever we move up, we are increasing y. So an increase in x leads to an increase in y. So the gradient is always positive. Whenever I see the line is going like this, there we have a positive gradient. So what about negative gradient? Occurs if an increase in x results into a decrease in y. So now y is going down, so it's decreasing. So here we say it's a negative slope or a negative gradient. Then the zero gradient, which occurs when an increase in x or decrease in x does not affect the value of y. So here, this one will say we are going to be having zero gradient. And these ones happen if we are having horizontal lines. When I get this ruler like this is in horizontal shape. So these lines like this are always having zero gradients. We are going to see why. And then according to horizontal lines, as you will see. Then undefined gradients occurs if an increase now or decrease in y does not affect x. So whether you increase or decrease y, the values of x are not changing. And such lines with such gradients are called vertical lines. Well, the moment you say line like this, we call them vertical lines, as we shall see. Slanting lines have either positive or negative gradients. Slanting, you see it's slanting now. These ones, either slanting like this, or like this. The slanting lines, either positive or negative gradients. Let us see how we find the gradient of a line segment passing through these points. We do not have gradient, the formula is here. All we need is to name the points. So if I call this x1, y1, x2, y2, I just substitute into the formula. So from here, I'll be having y2, my y2 is 5, y1 is 3, over x2 is 3, minus x1 which is 2. And so this one is going to give me 2 up over 1 down. 5 minus 3 gets 2. 3 minus 2 gets 1. And so our gradient here is 2. Positive. As simple as that. When it comes to 2, this one here, let me call this one x1, y1, and I call this x2, y2. So now my gradient from there, my gradient m, x2, y2, 0, minus y1, which is 1, over x2, which is 1, minus, but this one is minus 2. So up I'm having negative 1 over the whole of this. Now it's going to give me a positive. So I have 1 plus 2, which will be negative 1 over 3. And that is the gradient. So here the gradient is as simple as stating it as negative 1 over 3. As simple as that. It's a fraction. Now, when I come to this, of course, I call this one x2, y2. I call this one x1, y1. But if you call this one x1, y1, doesn't matter. The answer is going to be the same. Okay, let's see what we get here. y2 is negative 2, then minus, then y1 is negative 2, over x2, which is 3, then minus x1, which is a 1. And you see up we are going to be having negative 2 plus 2 over 2. This will be 0 over 2. And here we have 0. So that our slope is 0. Why? We saw that y was not changing. Negative 2, negative 2. So y there is not changing. The moment that the coordinates of y are the same in the 2 points, just know they are going to get the gradient as 0. As simple as that. So this is what we are talking about, the ones with the 0 gradient. As simple as that. Let us go into this. I call this one x1, y1, x2, y2. Let me see what I have. y2 is negative 7, then minus y1, which is negative 1, over x2, negative 2, minus x1, which is a 1. So this will be giving me negative 7 minus to give a positive 1 over negative 3. I mean, negative 2 minus negative 1, I mean minus 1, get negative 3. So up I have negative 6 over negative 3. How? Negative 7 plus 1 you get negative 6, negative 3. And so if you divide that, you get this negative, you get a positive. 6 divided by 3, you get a 2. So therefore here, our gradient is 2. So members, that's how we get the gradient of a line segment if you have any 2 points on that line. I wish you well.